All right. Hello. Okay, so I'll just be waiting for a little bit, just a few minutes, 5 minutes probably to be exact, and then we'll start. Wow, hello Shibe, long time, Shibe. Sure. I think the last time I saw you was in Pretoria. Anywho, so let people join in. All the people who are in grade 10, just come on through. We are deliberately coming through to actually do okay, so we'll be doing grade 10 functions. Okay, and specifically we'll be looking at hyperbola and exponential functions. Okay, so hopefully we can smooth into the two topics because they are important, and we need to know how to be able to answer questions that have to do with these functions. I think some of the grade 10s are actually exposed or have been exposed in this term to functions, so we'll be going through that. Oh nice, okay, but we'll be doing specifically these functions, the hyperbola and exponential, and we'll be looking at exam type questions, and then also as we go through these exam type questions, maybe if there are specific things as a grade 10 learner that you want to ask about, then you're more than welcome to ask about those things and get clarity on whatever you want to get clarity on. But we're doing this today. Okay, so let's look at the very first sort of like question that we have here. Okay, so we are given here f of x is equal to negative 2 to the power x plus 4, and g of x, which is equal to a over x plus q. Then we are given that g of x has the following properties. Okay, so that's specifically referring to this function. Okay, so f of x, guys, if you look at this function, what type of function is it? F of x is equal to negative 2 to the power x plus 4. What type of function is this? Do we all know the form of this function and which function it points to? Because that's very important. Identification of a function is very important. So you need to look at the form of a function and then be able to identify what type it is. Okay, so yes, this is an exponential function. So if you are grade 10, you should know that this is an exponential function. Okay, then you have g of x, which is a over x plus q. Do we also know what type of function this is? The form of the function, because that's also important for us to know the form of the function and what type it is. So yes, okay, it is a hyperbola. So we've got two functions here. We've got an exponential function and a hyperbola. Now I'm hoping that all of you know that when you have a form of the function like this, then of course there are various, we call them parameters. Okay, so this negative, all right, points to the parameter a, this 2 points to the parameter b, and then it's to the power x plus 4, and this parameter here points to q, and a, b, and q will tell us various things about the exponential function. And it's so important, guys, to know the form of the function and what the various parameters will tell you. Then you have g of x, which is a over x plus 2. So once again, this is a hyperbola. Your a and your q value will also speak to you about certain things that relate to that function. Okay, so I wanted to kind of like, before I answer the question, I wanted to summarize. Okay, I need to sort of help us understand that. Like I said, guys, we need to understand this, that for your exponential, okay, once you know these things, it makes life easy, very easy. So for our exponential, so just allow me to write in pen. For our exponential function, the form of the function is y is equal to ab to the power x plus q. Okay, now this here, this a, when it is greater than 0, okay, it means that a is positive, in other words, right? And when that is the case, we mean that the function will always be found above what we call the asymptote. Okay, so that's when a is greater than 0. If a is less than 0, meaning when it's negative, all right, then the function will not be found above the asymptote, but it will be found below your asymptote. Now, guys, your asymptote has everything to do with the value of q. So q here, whatever the value of q is, all right, that will give us what the asymptote, the value of our asymptote will be. So it's the asymptote is a horizontal one. Okay, we have what we call a horizontal asymptote where the exponential function is concerned, and so though we say y is equal to that q value, whatever it is, will give us the equation of the horizontal asymptote. Okay, then the b value, the a together with the b, will tell us as to where do we find the function. As it is above the asymptote, is it an increasing function or is it a decreasing function? And b can only be in two forms. B can either be a value that is between 0 and 1, or b can be a value that is greater than 1. And that's it. Okay, so b can either be a value between 0 and 1, or b can be a value that's greater than 1. Okay, so that's what's important about an exponential function. Like I said, the form is ab to the power x plus q. A and b together, right, will give us the idea as to whether what is the shape, the position of the function that is exponential. Okay, so that's just a brief summary. Okay, so like I said, if a is greater than 0, all right, meaning this value is greater than 0, then if the asymptote is like that, you can either expect the function to be like that, that's given that b is greater than 1, or if it's above the asymptote, it can also be like that, that's given that b is between 0 and 1. Okay, so these are both cases where a is greater than 0. If a is greater than 0 but b is greater than 1, this is the form. But if a is greater than 0 and b is between 0 and 1, then you can expect this shape and this form of your exponential function. And that's very important. Okay, and remember, like I said, this asymptote, which is horizontal, is given by y is equal to whatever the q value of your exponential function is. Okay, so once you know those basics, it makes life very easy. Okay, so that's when a is greater than 0. Now let's see if a is less than 0. When b specifically is the one that is greater than 1, then you can expect your shape of the exponential function. Yes, it will be below the asymptote, but look at it, the function will be decreasing. But if a is less than 0 and b is between 0 and 1, that will be your graphical form of the function. You can expect that if a is less than 0, the function will be found below the asymptote, of course, okay, but it will be an increasing function in that way. So these are important things here, guys, to note about these functions, okay? Like I'm going to repeat again. If a is greater than 0, but at the same time b is greater than 1, this is your form. You can expect an increasing exponential function that is found above the asymptote, because remember I said when a is greater than 0, the function is always going to be found above the asymptote. If a is greater than 0 but b is between 0 and 1, usually a common fraction would indicate this, where your denominator is a small number and your numerator is a small number and your denominator is a big number. That's when a value is between 0 and 1, okay? That's what we mean by that, okay? So basically, this is your shape and your form. If a is greater than 0 but b is between 0 and 1, your function will be found above the asymptote, but it will be decreasing, okay? So we call this, let me just say it as well, this is an increasing function. This one is increasing, but this one is decreasing. Okay, look at it, it's going up, but here it's going down. So that's why we call it a decreasing function. Look at this one. This one is going down. This one is going up. So we call this a decreasing function, and then we call this an increasing function. Okay. So these are important things to understand about the parameters of a exponential function. As I said, this is the form of the exponential function, a, b. This a and the b will tell you about the function's shape and position. If a is greater than 0, the function is going to be found above the asymptote. What is the asymptote? The asymptote is just a boundary line where the function cannot exist or where it does not touch. It's like a boundary line, okay? And we usually represent it in this way. It's not a solid line, but it is like a spaced out boundary line, if you know what I mean. Then if a is greater than 0 and b is greater than 1, increasing function above the asymptote. If a is greater than 0, b is between 0 and 1, then it is a decreasing function above the boundary line. If a is less than 0, on the other hand, remember when we said a less than 0, it means that the function is found below the asymptote. So if a is less than 0, but at the same time b is greater than 1, we have a decreasing function below the asymptote. And then if a is less than 0, but b is between 0 and 1, then we have an increasing function below the asymptote. And as I said, this q value as it is will tell us what the value of the horizontal asymptote actually is, okay? So I hope that makes sense. Now I want to come here, this question, because I want to look at this. We'll look at this later. Look at this one. Sketch the functions below. Clearly indicate all intercepts with the axes, turning points, and asymptotes. Okay, so here we are asked to sketch the function f of x is equal to negative 2 to the power x plus 4. Right, now please take note. I'm going to just use the same paper here. Y is equal to negative 2 to the power x plus what? Plus 4. Now I hope you guys can see this and see it as well. So if I was to write the form of the function y ab to the power x plus q, what is the value of a here? Can someone tell me what is the value of a? Do I have the value of a here? And then also, what is the value of b from this function? So what's the value of a? Let's start with the value of a. What is the value of a? So random says it's 1. Do we all agree that the value of a is 1? Just tap, he says it's negative 1. Okay, and so do the following viewers say the same. So yes, guys, please, let us be very clear. The value of a, guys, is negative 1. So a would be in this position. What we have here is a negative sign, but this negative sign means negative 2 times Negative 1 times 2. So the value of a here, guys, is negative 1. Okay. The value of a is negative 1. I hope we are in agreement there that a is actually equal to negative 1. All right. Because as I said to you, the exponential form of the function is given by ab to the power x plus 2. What we have here is a negative sign, and then we have a 2, and then we have to the power x. Now there are conditions placed on the parameters which I did not really discuss, and that is the following. The value of b, guys, this is what we know about the value of b. The value of b can never be 1, and the value of b is actually never going to be a negative number. Can't be negative. The value of b can't be negative. Okay. All right, so I hope you understand that this base to this variable exponent can't ever be equal to 1, and it can't ever be negative. So that is why, for instance, when we come here, we need to then say that this negative sign simply represents a negative 1 multiplied by 2 to the power x. I hope you understand me now. This negative sign is a negative 1 multiplied by 2. So there is an invisible 1 that is multiplied to the 2, which is why we say that our a value is negative 1. Okay? All right. Yeah. So hopefully it makes a bit more sense. Okay. Remember, guys, I was given this function. F of x is equal to negative 2 to the power x plus 4. All I'm doing now is I'm identifying a from the function and b from the function. So I'm saying our a value, though we cannot see that it is negative 1, it has to be that our a value is negative 1. Why? Because our b value can never be a negative number. Our b value can either be a number that is greater than 1, or it can be a number that is between 0 and 1, but it can't ever be a negative number. So that means then our a value must be negative 1, because our a value here, okay, must be a number multiplied to 2, and that is surely negative 1, because a negative 1 times the 2 makes us understand why it is that we have negative 2 to the power x. So I hope that makes sense now. So we say a is negative 1. Our b value, on the other hand, is actually equal to what? It is actually equal to 2. Okay, so a is negative 1, b is positive 2. All right, so I hope that makes sense now. So understanding that means if we unpack this function, where do we find the function? Because a is negative 1 and b is positive 2. Let's go to our various conditions that we said will help us understand the shape and the position of the function. So a here is a negative number, meaning it's less than 0. So we are going to come down to these two options. When a is less than 0, we know that the function is found below the asymptote. A less than 0, the function is found below the asymptote. As we said, when a is less than 0, the function is found below the asymptote. But what is the value of b? B is positive 2. So remember, when b is greater than 1, this is the shape of our function. It is a decreasing function found below the asymptote. When you know this, guys, then you are not surprised when you see your function and when you draw it, because you know what a does to the function, you know what b does to the function. So when you know the combined effect of a and b to your function, then you will be able to see or expect a certain shape of the function and position in relation to the asymptote. Okay, so that's why I'm saying to you guys, please know the form of an exponential function. Understand that it has an a, there's a b to the power x plus 2. Understand what a does, that when a is greater than 0, the function should be found above the asymptote. Simultaneously, when you understand the combined effect of a and b, under different situations. For instance, when a is greater than 0 and b is greater than 1, that the function is increasing, it's found above the asymptote. That when a is greater than 0 but at the same time b is between 0 and 1, that the function is found above the asymptote still, but it is decreasing. That when a is less than 0 and b is greater than 1, that the function is found below the asymptote, but it's decreasing. When a is less than 0 and b is between 0 and 1, the function is below the asymptote, but it is increasing. When you understand the dynamics here, then it makes it easier for you to see in your mind's eye how will the function be. So remember, we are supposed to sketch this function. Okay, I know a is negative 1, b is positive 2. So as I prepare to sketch, in my plan, I can know that because a is negative 1 and b is equal to 2, what am I expecting? I'm expecting a function, already in my head, I'm expecting a function that will be like that. It will be a curve below the asymptote. The function will be a curve found below the asymptote. If I know what my q value is, then I know my asymptote will be that. So that's my plan. But yeah, that's what I see in my mind's eye. But what do we need to find in order to sketch a function? Remember, there were a couple of things that they said. They said clearly indicate all intercepts with the axes, turning points, and asymptotes. Okay, so let's write down what is the horizontal asymptote of my function, the exponential function. Let's see if people know what the equation of the horizontal asymptote is. This was the function, right, that I'm given. What is the equation, guys, of the horizontal asymptote of this exponential function? What is the equation of the horizontal asymptote of this exponential function? What is the equation of the horizontal asymptote of this function? I repeat, what is the equation, guys, of the horizontal asymptote of this function? I want the equation. Wait, before we find the x-intercept and the y-intercept, I want the equation of the horizontal asymptote. Remember, if I know my boundary line, first and foremost, before finding the x and the y-intercept, then I know where my function is going to be found. Alright, so I need you guys to tell me what is the equation first of the horizontal asymptote. Y is equal to negative 2 to the power x plus 4. This exponential function, what is the equation of the horizontal asymptote? Okay, so Kelsey says y is equal to q. Now, Kelsey, you are right in saying y is equal to q, but remember, now that we have a specific function, who is in the place of q? Because I don't write that q value, I don't write y is equal to q, but I write specifically whatever is in the place of the positive q. So what is in the place of q here? Do you see that? So the horizontal asymptote then is going to be, instead of saying y is equal to q, because we were obviously speaking about it generally, but now we have a specific function. So what is the equation of the horizontal asymptote? It is y is equal to 4. Very true. Okay, just happy. I'm glad that you also on board there. So we have y is equal to 4. Okay, so this is for the grade 10s, guys. Grade 10. I've got my grade 10s here, but of course, this will not hurt a grade 11 learner and a grade 12 learner because it's exponential functions. So yes, the horizontal asymptote is y is equal to 4. How did I get it? Guys, in the place of q, we have 4. So when we write the equation, we are going to write y is equal to 4. If there was a negative 4 here, I was going to write y is equal to negative 4. If there was a negative 2, I was going to write y is equal to negative 2. So remember, the horizontal asymptote is whatever is in the place of the q value. So I say y is equal to 4. I hope we are together here. Okay, so my value of the horizontal asymptote is given by that q value, whatever it is. It is there. Here we have 4. Okay, could you repeat the question? Guys, I was asking what is the equation of the horizontal asymptote. Okay, I was asking that. Okay, because I'm given the function y is equal to negative 2 to the power x plus 4. So I was asking from this function, what is the equation of the horizontal asymptote? Okay, so then we answered, okay, it was, for instance, Kelsey said y is equal to q. And when Kelsey says y is equal to q, remember, she's speaking under the understanding that our q value gives us the equation of the horizontal asymptote. Now we've got a specific exponential function. In the place of q, we have the value of 4. So when we're asking what is the horizontal asymptote, the boundary line, okay, where the function does not touch, it has to be y is equal to not q, but because there's in the place of q4, we say y is equal to 4. That is our horizontal asymptote. Okay, so I think our plan is going nicely so far. We've identified a is negative 1. We've identified b is positive 2. And from that, we have an understanding now as to where we are expecting the function to be found. We are expecting the function to be found below the horizontal asymptote, and it's supposed to be a decreasing function because we understand that when a is less than 0 and b is also greater than 1, then this is how our function should be. Then we identify the horizontal asymptote, point number 2. Now 3, we need to find the x-intercept and the y-intercept. Why do we do that? Because when we have the x and the y-intercept, it helps a lot, okay? It helps us a lot to be able to sketch our function. So let's check if we do have the x-intercept. To find the x-intercept, guys, what do? We let what? Let me see in the comment section if people are still with us. When we want to find the x-intercept, we let what, guys? What do we let? Want to find the x-intercept? We let y be equal to 0. Thank you, guys. You are amazing. So let's go to the function. There it is. Remember, there was f of x, but we know f of x means y. So in the place of y, it means we are going to substitute 0. So I'm going to say 0 is equal to negative 2 to the power x plus 4. Okay, so in the place of y, I write 0. 0 is equal to negative 2 to the power x plus 4. I transpose the negative 4. That gives me negative 2 to the power x, and then the other side I take the 4 over, it becomes negative 4. Okay, then of course you can see, guys, that this is a base. It is an exponential base. All right, and this side I've got the base 4. So you make the bases very good. I like what someone is saying there in the comment section. I like this. So we make the bases the same. So base 4, how do we change base 4? All right, so that it has the same base as the side. Remember, this 2 is a prime number. So it's very important to change our composite base to a prime base. Okay, so we let it be 2 to the exponent 2. I like that. So okay, very nice. Our bases are exactly the same with the same sign, and this is very important. When the bases are exactly the same with the same sign, then what we can do is we can drop our bases. Literally, we can drop our bases and we can equate the exponents. So that means x, which is that, will be equal to 2. We drop the bases and we equate, we make the exponents equal. So x is equal to 2. So that means when y is 0, x is equal to 2. So that means these are our coordinates of the what? Of the x-intercept. Okay, we are done with the x-intercept. Now it's time to go and find the y-intercept. Okay, so let's go and find the y-intercept. When we find the y-intercept, what do we do, guys? What do we let? You guys seem to be on fire there in the comment section. It's like these boys and girls are on fire. These men and women are on fire. What do we do, guys, when we want to find the y-intercept? We let what? You guys are on a roll already. Might as well. Nice, Natty 188. You are truly with us. We let x be equal to 0. Very good. So that means we go to the function again, letting x be equal to 0. We say y is equal to negative 2 to the power 0 plus 4. Now let's be very careful. Negative 2 to the power 0. Now let me check how well people know their stuff. What's negative 2 to the power 0? What is that actually equal to? Be very careful. What's negative 2 to the power 0? Seems like everybody is saying 1. You'll be very shocked, guys, when you put these things in your calculator. Eh? And I hope we all are understanding that this even exponent will apply to the 2 only, not to its negative side. Okay. You'll remember, guys, I said to you, what's this? Negative 1 times 2. You see, you remember what I said there? So this, when I substitute 0, the 0 will, this even 0 exponent will apply to the 2. 2 to the power 0 is 1. But 1 times the negative 1 will still give me a negative 1. So the answer is negative 1. And that's very important to understand that. Okay. For ease, if you put this all in your calculator, you can simply just get the answer straightforward. But be very careful. Let us be very careful with this. Okay. Where do you get basics? You get basics at school. Tends to be the place where people don't want to really listen the most, actually. Hey, that's why rowdy classes will forever be what do we call? They'll forever be a fighter against basics. When classes are allowed to be rowdy and there's no order, discipline in a classroom, that's what kills basics. But you get basics from school. Yeah. But also, I help with people to get basics if they want. No, guys. This one, remember, this one was for this one. Okay. Now we are dealing with this. Negative 2 to the power 0 is negative 1 plus 4. 4 minus 1 is 3. So our coordinates, when x is 0, y is 3. This one was for this one. Okay. Can't remember none of this stuff. Joy Mofukeng, are you just here for fun, for leisure? Or are you someone who wants or needs to have these basics down because you'll be writing at some point? Yes, you can, Bingo. You can definitely ask, but yeah, you can definitely ask. Okay, so guys, you see our coordinates. So now we are good to go. I think we can go and try and sketch now our function. So first things first, do you remember what I said to you? Finding the horizontal asymptote. Very important to find the horizontal asymptote. Y is equal to 4. So let's go to our Cartesian plane. 1, 2, 3, 4. Y is equal to 4 is here, guys. So what we first start doing is we draw in our horizontal asymptote. You will use your ruler. You will draw a horizontal, sort of like spaced out line like this. Then you're going to mark it and say y is equal to 4. No, Joy. This is not a straight line function. This is an exponential. Okay, this is exponential. Okay, for those who have been here, remember horizontal asymptote, y is equal to 4. We found the horizontal asymptote and we said it's y is equal to 4. So what I'm doing now is I'm going to my Cartesian plane. I go and identify. Remember, this is the y-axis. This is the x-axis. And on my y-axis, I have my y values that you can see here. All right. And each y value, remember, y is equal to 1. Y is equal to 1 is everywhere on this horizontal line. Y is equal to 2 is everywhere on this horizontal line. Y is equal to 3 is everywhere on this horizontal line where 3 is. Y is equal to 4 is everywhere on this horizontal line. So that's why you see me when I draw in my horizontal asymptote. Remember, this is a boundary line. Asymptote is where the function cannot exist. That's where the function does not touch, does not cross, does not overlap that line. So we have that asymptote in there. We need to first draw it in. Why do we first draw in the asymptote for our exponential function? Because remember, we established that when a is negative or less than 0 and b is greater than 1, we expect our exponential function to be this shape. That's what we are expecting. Okay, now we are just going to see the manifestation of what we expected in our minds and in our hearts. Check it out. It's gonna come about. Okay, so far we've drawn in our horizontal asymptote. Just by doing that, guys, you get a mark. You get a mark for drawing in your horizontal asymptote. That's why you start with it, and then you label it. Y is equal to 4. Okay, easy marks, right? Easy 1 mark. Hi guys, easy 1 mark, that one. Then remember, we wrote down, we found our x-intercept. How did we find the x-intercept? We let y be equal to 0. Then after letting y be equal to 0, we substituted. Okay, great tens. We substituted most great tens. We substituted great tens. We substituted in the place of y 0 equal to negative 2 to the power x plus 4. Then we transposed the 4, took the 4 over, became negative 4. Then after it became negative 4, we saw, since this is an exponential equation, we changed the bases so that they are both prime. This negative 2 is already a prime base, so we changed the 4 into a prime base so that it is expressed in exponential form. When the bases are the same, we saw that negative 2, same bases, we drop the base, we equate the exponents, so x is equal to 2. That's how we got 2 and 0, which are our x-intercepts. What is an x-intercept? It is where the graph cuts the x-axis. Where is the x-axis? Here's the x-axis. Where are we cutting the x-axis? At what? At 2. Where is 2? 1, 2. So we are cutting here. So we are expecting our to be there. We're expecting the cut to happen there, where x is 2. Are we together, guys? So 2 and 0 is exactly here on the x-axis. That's where 2 and 0 is located. Let's move on. So our x-intercept, we have located the point on our x-axis. There it is. It's x and it's 2. It's there. 2 and 0. It's there. Okay, this is called 2 and 0. This is the point 2 and 0, where x is 2 everywhere on this vertical line, but where y is 0. Y is 0 everywhere on this x-axis, so they meet exactly there. So 2 and 0 is there. Lastly, we want to find the y-intercept. We let x be 0. This is where the graph cuts the y-axis. Okay, so there we cut the y-axis. We just go there. Okay, we just go there. Okay, then we locate, we got our we got our y-intercept most there. Okay, so 0 and 3 here. Okay, where y is 3. All right, but at the same time x is 0. Okay, yeah, then there it is. Okay, so now when you see this is very clear that, oh, nice function, right? Arrow. Okay, do you see that? So when we use this dual intercept method approach, in other words, when we say dual, it just means that we find the 2 intercepts. And rightfully so, we expect to be able to find the x and the y-intercept. Do you know why? Because even from the beginning, we expected, since a is negative 1, a is less than 0, and b is 2, in our heads already when we started sketching, we expected the sort of shape of the function. Why? Because we as maths gamers, we know that when a is less than 0 and b is greater than 1, this is the position of the exponential function. We're expecting to find it below the asymptote, of course, right? And then decreasing function. And because we know the horizontal asymptote is y is equal to 4 and it's found way above the asymptote, it means our function is going to be found below, and it will definitely have a y-intercept. It will definitely have an x-intercept, which makes life very easy, right? So that's why even in our mind's eye, we could expect that we will have to find the x-intercept. Let y be equal to 0. We'll have to find the y-intercept. Let x be equal to 0. Find our points, x is equal to 2, and find our points so that y is equal to 3. Our points 0 and 3, which is the y-intercept, and our points 2 and 0, which is the x-intercept. So the dual intercept method here works nicely for this exponential function. Mark shape. Beautiful. All right, no marks lost. Do you see? No marks lost at all. Gained everything. Okay, so the exponential function has one asymptote. It's called the horizontal asymptote. The exponential function does not have a vertical asymptote. So I hope that is very clear for all of us. So this from here, guys. Okay, let me just state from here. This is kind of where we started looking at how to sketch our exponential function. Y is equal to negative 2 to the power x plus 4. We call this an exponential function. And I said that an exponential function is in the form y is equal to ab to the power x plus 2. This is the form of an exponential function. There's an a, there's a b. Once you understand that there's an a and there's a b, and from this we can read what the a value is. It's negative 1. How? Because the b value is never ever going to be negative. So there must be a negative 1 times by the positive 2. Hence we have a negative 1 times 2. So a is negative 1, but the b is 2. Our horizontal asymptote is always given by the q value, which is the constant that is here. So y is equal to whatever the constant value is. That is our q value, our horizontal asymptote. That's why when I said horizontal asymptote, it's y is equal to 4. Then when I know what a is and what b is, I go directly to what I know about a. When a is positive, guys, and at the same time b is greater than 1, this is the shape I'm expecting. Remember, a greater than 0 just means the function is above the asymptote, whereas a is less than 0 means the function is below the asymptote. Remember this. When a greater than 0, function above the asymptote. But when a is greater than 0 and b is greater than 1, we are above increasing. A greater than 0, b between 0 and 1, we are above decreasing. A less than 0, b greater than 1, we are below, because when a is less than 0, the function is found below the asymptote. We are below and decreasing. A less than 0, b between 0 and 1, we are below and we are increasing. Guys, when you know this, when you know this guy, exponential functions are weak. And remember, q, equation of the horizontal asymptote, y is equal to whatever is in the place of q. If it's positive, it means y is equal to that positive value. If it is negative, it means y is equal to whatever that negative value is. And remember, guys, here, when I sketch this function, we got a is negative 1, b is equal to 2. We expected the shape because we know our conditions. So we expected. In my mind's eye, in my planning, I know exactly what to expect from my exponential shape. So I find my horizontal asymptote. It's y is equal to 4. Okay, remember the q value as it is, y is equal to 4. X-intercept and y-intercept I could find. Guys, remember there are cases where the y and the x-intercept, sometimes you will not be able to find them. Think, for instance, of this situation. If this was negative 4 instead of positive 4, okay, let's say this q value was negative 4, then it would mean that the horizontal asymptote would be found below here somewhere. But then the function will also be found below the asymptote. So that means there's no x or y intercept there. If there's no x or y intercept because the function is found below, there will be a y intercept, but there will be no x intercept. So if that is the case, if there is a y intercept but there's no x intercept, what do you then do? Then you can use your table method and find one x value on the negative side, one x value on the positive side, and then connect those points so that you can actually see the shape of the function at least. Okay, so there are situations, guys, where sometimes the x-intercept, you cannot find it simply because the asymptote is basically making it such that, you know, and the a and the b value are making it such that the function is either found above or below the asymptote where the x-intercept cannot be located. Okay, so there are situations like that, and that's where table method helps. Okay, so your table method will help you in situations where the x-intercept, you do not have one. Okay, okay, let's where a over x plus 2 is the form of the hyperbola function, we are given that g of x has the following property. Okay, now these are the properties. We are told that the range is y is an element of R where y cannot be 4. This is the range. Now guys, this is very important, these types of questions, because nowadays when they ask people to sketch functions, they use properties to sort of like, you know, lead people towards the sketching of that particular function. So as a grade 10 learner, you need to be very well versed in understanding, you know, as a grade 10, you need to understand the properties. The A, what does it mean? The Q, what does it mean? That's why I'm explaining these things, because you need to understand these things in order to be able to move. Okay, so they are saying that the range is y is an element of R, y cannot be 4. A is less than 0, meaning this A value is less than 0. That should speak to you about something. They are then saying the x-intercept is 2 and 0, of course. And then they are saying for g of negative 4 is equal to 6. In other words, when we substitute our x value negative 4, we get a corresponding y value, which is positive 6. In other words, that's a point in negative 4 and 6 that is found, or that lies on the function. Okay, so first and foremost, before we jump into this question, we need to unpack the hyperbola function just a little bit. Then we can actually answer the question. So just bear with me here. First and foremost, hyperbola. Okay, so I'm just gonna provide some space here. Let's just see if we have the same understanding here with the hyperbola. So the hyperbola function, okay, we all agree that the form of the hyperbola function in grade 10 is y is equal to a over x plus q, right? Now, when a is greater than 0, what does it mean for a hyperbola function? Now, we understood what a greater than 0 meant for a exponential, but now we need to understand what a is greater than 0 means for a hyperbola function, and we need to understand it and understand it well. So this is what it means. When a is greater than 0, before we even jump into a, we need to understand that the hyperbola function has two asymptotes. Okay, there is a vertical asymptote. That is, in grade 10, the vertical asymptote is always given by the equation x is equal to 0. In grade 10, I need to be very specific here, that in grade 10, you know, if you are doing caps, the asymptote, the vertical asymptote for our hyperbola function is given by x is equal to 0. The horizontal asymptote is given by the equation y is equal to q. Now remember, guys, you don't write y is equal to q. You will write y is equal to whatever that q value is. So there are things that are shared between your hyperbola and your exponential function, and that is where our horizontal asymptote is concerned for an exponential function. We say for an exponential function, the horizontal asymptote is y is equal to q. So it is true for a hyperbola function. The horizontal asymptote will be y is equal to whatever the q value is in grade 10. I need you to understand that in grade 10, in grade 10, in grade 10, that is the case. X is equal to 0 in grade 10. Because in grade 11, obviously, there are certain things that happen in the denominator of the hyperbola function, which make it that sometimes the vertical asymptote is not x is equal to 0. You know, it can change. Okay, but in grade 10, guys, vertical asymptote is x is equal to 0. Your horizontal asymptote will be y is equal to q. Okay, so I hope that's clear for us that we have these two asymptotes. That's the first thing I need to make very clear before anything. Vertical asymptote, horizontal asymptote. Vertical asymptote, horizontal asymptote. Now listen to me and listen to me well. When a is greater than 0, I need you to grasp this too. When a is equal to 0, our function, this speaks to the position of the function and its shape as it relates to its asymptotes. So we say that our function is found in the first and third quadrant of the asymptotes. When a is greater than 0, the function is found in the first and the third quadrants of the asymptotes. Guys, of the asymptotes. I underscore that point. First and third quadrant of the asymptotes. So in other words, it's the odd quadrants, the odd number quadrants. We have 4 quadrants, guys, in total. Only 4 quadrants. So if a is greater than 0, the function will be found in the first and third quadrants of the asymptotes. In other words, it's found in the odd quadrants. When a is less than 0, then we are talking about the even quadrants there, the second and fourth quadrant. Okay, the second and the fourth quadrants, meaning the even of the asymptotes, right? So we say there that they are found in the even quadrants. Yeah. So if we tlhaloganya this, then I people, we are good. Okay. And I've already explained the fact that we have 2 asymptotes. So that is why then it's important first and foremost to establish what the asymptotes are. Once we establish the asymptotes, then the sketching is easy, because if a is greater than 0, we know first and third quadrant, we expect the function to be there. So I just want to diagrammatically show you what we mean by this. So if we look at the first situation, a greater than 0, let us say that we know, we establish that our y-axis, which is x is equal to 0, will always be the vertical asymptote in grade 10. Then let's say this is the horizontal asymptote, y is equal to whatever the q value is. Now obviously the x-axis will be located anywhere. The reality, guys, is that once our asymptotes are there, meaning the y-axis and the horizontal asymptote, y is equal to whatever the q value is, that means if we are talking about a greater than 0, we expect our function to be found in the first and the third quadrant. You go sleep. Yes, snuggle bunny. That's exactly it. That's what I mean. Okay, a greater than 0 means first and third quadrant. Okay, yeah. Please. So you always need to sketch in your quadrants first, then draw. Okay, so I hope that makes sense. Then this one, a less than 0. Okay, so once again, as a grade 10 learner, your y-axis is the vertical line, that is x is equal to 0. Then remember, whatever the horizontal asymptote is, okay, y is equal to q, you will actually now draw in your function, it will be situated in the second and fourth quadrant. Please take note, the curve, nice smooth curve. Okay, yes, Nagobani, definitely, because remember, if a is less than 0, what type of function is this? This is increasing, it is increasing. So we say when a is less than 0, it is an increasing function. Okay, but when a is greater than 0, you can see the function is decreasing here. Yeah, I can see Snuggle Bunny loves snuggling with math, eh? Yeah, such questions, most obviously, and such comments will only be made in the comment section if someone is really snuggling with maths. This is what you guys need to do if you want to get very good at the maths and to get the nice marks. You need to snuggle with maths, you know? Very important to snuggle with maths, snuggle and be very close to maths so that you can ensure that you are practicing it often and doing it often so that it becomes familiar, it becomes second nature. It's like anything, man, that you do over and over again. It becomes second nature. After some time, it's like you don't really need to study for the thing because it's just something you like, right? You love it. So hopefully this makes sense now that if a is greater than 0, we're saying first and third quadrants of the asymptotes, okay? And your quadrants are in accordance to the asymptotes. So this is what we call our first, second quadrant, third quadrant, fourth quadrant. The asymptotes define the boundaries of the quadrants. Likewise here as well, first, second, third, fourth. Okay? So hopefully this makes sense now. And we are good. We are good for it. Okay, so these are the basics. You know, once you know this, at least now you can expect certain things. So let's come back to the question here. We are told, given that g of x has the following properties, the range is. Now hopefully we all understand that if they are saying the range is, the range will tell you where does the function exist and where it does not. So if they say y is an element of R, that means the function exists for all y values, but then y cannot be 4. So I can tell you from the get-go that our function here is going to have a horizontal asymptote of y is equal to 4. I know that because the range is what we call the possible y values. Range means y values. It's the possible y values where our function that we are drawing or we are expecting to draw will exist. It will exist in certain places, but obviously there at the asymptote, the function does not exist. So that's why we say y is an element of R. The function will exist everywhere. I usually say to my learners that this ER means everywhere. It's like, you know how everywhere, when you spell it, has everywhere. So I usually say that this ER here, element of R, means everywhere. So the function is found for the y values, it's found everywhere for the y values. Meaning from the bottom to the top, the function is found everywhere. The only exception is here. Okay. Y cannot be 4. In other words, y cannot be found where y is 4. We can't find it there. So that means our horizontal asymptote, where the function is not found, is y is equal to 4. Okay. Then of course our vertical asymptote, as I said in grade 10, okay, isolated x in the denominator. What can we divide? What can't we divide the denominator by? We can't divide the denominator by 0, which means x cannot be 0. So Oh. Okay, just a sec, guys. I'm gonna be with you just now. For now, tell me what you think about this. Does this make you guys happy? This log. Current situation. Okay. Yeah, I don't think too many people like the current log standings, but anyways, let's leave sport behind. Were you not doing math? Yeah, maths and sport. Remember, this is the channel. This TikTok page is called Maths is a Game, and everything that is a game here is entertained. Down to sporting games and everything, the works. All right. So anyway, sorry, back here. So I think, guys, I hope we have established that the range here we are told is y is an element of R. Remember, guys, that when we talk about range, it's like we are looking at the situation of this function from the bottom. What's happening from the bottom going up? Okay, that is range. Range has to do with from the bottom to the top. We are looking from the bottom to the top. Where does the function exist? From the bottom to the top. That's a range. But we see that y is an element of R. In other words, the function is found for every y value from the bottom to the top, except where y is 4. Y cannot be 4. The function is not found there. Okay, and that makes sense, because if y cannot be 4, then that means that the place where the function is not found is what we call the horizontal asymptote. Okay, so y is equal to 4 is our horizontal asymptote, the place where the function is not found, or where the function does not exist. Okay, then, as I said, the possible y values, that's what range tells me. The possible y values where the function exists. Laura D, it's not my network, it must be yours. Okay, I have good network. So you guys, every time you come here and you tell me network, you must check your network, please. My network is on tip-top shape. Okay, so the range is that. So hopefully we understand that. Then a less than 0. Yes, it will be. A less than 0. What does a less than 0 mean? Oh, it lags a little. Okay, so sorry, I was arrogant then about that. At the moment, it's not showing anything. My mind is saying connection. Okay, yes. So a less than 0. Remember, we established this. When a is less than 0, we said we can expect to find the function in the second and the fourth quadrants, in the even quadrant. And we are also anticipating that the function will be what? Will be an increasing function. Hi. We are one step close to sketching, because we know where the asymptote is, the horizontal one, and we know where the vertical one is, because it's greater than a isolated x in the denominator alone. All right. Then a less than 0, second and fourth quadrant. So we even know where the function will be situated. Now, x-intercept is at 2 and 0. Oh, we have the x-intercept even. Okay. We have the x-intercept. Do we expect to have a y-intercept here? Definitely not. We can't. Because remember, if you let x be equal to 0, you are definitely going to have a situation where your calculator is going to say maths error. Division by 0 is not allowed, So we are not going to have a y-intercept for your hyperbola function, because the vertical asymptote, where the function it does not exist, is x is equal to 0. So it makes sense that we only have an x-intercept. Then they additionally give us another point so that we can, for one of the other arms of our function, we can know where at least we can roughly have it, So I'd say we are good to go. We are good to draw. We can sketch. We can sketch. We can sketch. Why cannot be 4? Okay. I don't understand, Senna. What do you mean I don't understand? What don't you understand? What don't you understand? I don't understand, Senna. What don't you understand, Calvin? You need to help me understand what you don't understand. Which bullet point? Bullet point 1, bullet point 2, bullet point 3, bullet point 4, or everything? The intermission of Kaiser Chiefs made you not understand. Bullet 3. Okay. What is the x-intercept? This is where we let y be equal to 0. Right? So this is where the graph cuts the x-axis. Where does it cut it? It cuts it where x is 2. Right? And where y is 0. Okay, that's what this means. Okay? And what I'm saying is that we only have the x-intercept, but we don't have the y-intercept. Does it make sense why we don't have the y-intercept? I am saying yes, it does. We can't have the y-intercept because remember, the asymptote where the function does not exist is where x is equal to 0. We can't have a y-intercept for this hyperbola function. Grade 10 learners can never have a y-intercept at all, because where we would say the y-intercept would be, that's where the function does not exist. The function does not exist where x is equal to 0. The y-axis is a place where the function does not touch, it does not cross, it does not overlap, it does not intersect at all. So the x-intercept is fine, but we can't have a y-intercept because of the asymptote, which is x is equal to 0, the vertical asymptote. Okay. Calvin, smile. It's impossible to ask you to find the y-intercept for the hyperbola in grade 10. In grade 10, the hyperbola does not have a y-intercept. I repeat, in grade 10. In grade 10. Okay, that's the entire y-axis. The entire y-axis is a place where the function cannot touch or ceases to exist, doesn't exist there, cannot be defined there at all. Okay? Are you with me now? Are you sure? Are you lost? You need to find me. Are you sure? Okay. Then this one. This here, guys, Remember, when they say g of -4, remember, this value -4 is coming in the place of x. So it means a certain x value, which is -4, when substituted in this function, gives us a certain output value, which is y, which is 6. So x is -4. When x is -4, the output value y is +6. This is a point that lies on the function g of x. -4 and 6 is a point that lies on the function. Okay, it is a point when x is -4, y is +6. Okay, I hope you understand that one. This is a point that lies on the function. It's a point that is existing on the function, -4 and 6. All right. So I'm going to show you now. We have to sketch. We can sketch. It's possible to sketch, right? In my plan here, I'm expecting that with the vertical asymptote, we are expecting the function to be found, because a is less than 0, we're expecting it to be found in the second and the fourth. So in my plan, I'm expecting that. So let's go, guys, and now sketch this function using all the details that we've just identified. So let's come here. Let's come there. So this is our y-axis, the equation x is equal to 0. One of our vertical asymptote. This is our vertical asymptote. And remember, there was that horizontal asymptote, which is y is equal to 4. So let's just say y is equal to 4 is existing there, right? This is just general, guys, all right? But yeah, hope you get the point. Let's just say y is equal to 4 is there. So 1, 2, 3, 4. Are you with me? Okay, so 4 is there. That's why we say y is equal to 4 is everywhere on this horizontal line, the equation y is equal to 4. Now, what are the quadrants? This is quadrant 1, quadrant 2, you see, because the asymptotes define the boundaries of the quadrant. This is quadrant 3, all of it here. This is quadrant 4, all of it here. But according to our information, we are expecting what? So the range, okay, since we know range y is an element of r, y cannot be 4, that helped me draw in my horizontal asymptote. 2, a is less than 0. I'm expecting the function to be found in the second and the fourth quadrant. Okay, let's get some points for the respective quadrants. So x-intercept is 2 and 0. That's going to help me with something. 2 and 0, where is 2 and 0? Okay, so let's just say 1, this is 2. So 2, x is 2 here on this x-axis. Okay, yeah, x is 2 is everywhere on this vertical line, but 2 and 0 specifically, where x is 2 and y is 0, is exactly here. Okay, this is the point 2 and 0. Okay, I hope that makes sense. Then 4, -4 and +6. Let's go to our graph. Let's just say that was -1, -2, -3, -4. So -4. And then 6, +6. +6 is somewhere here. Let's just say +6 somewhere here. So basically, we are checking where do these two meet. Because remember, x is -4 is everywhere on this vertical line that passes through this -4. That's x is -4. I just want to make this point very clear. X is -4 is everywhere on this vertical line. Y is +6 is everywhere on this horizontal line passing through 6. Where do the two meet? This vertical and this horizontal, they meet there. So that means -4 and 6 is exactly there. That's where it is. Okay. So if I'm going to sketch now, I'm going to sketch this curve, nice curve like that. Okay, and then here okay, and I make sure, guys, that this, you see, we don't touch this y-axis because it's a asymptote. Okay, all right, and then we don't touch this horizontal asymptote as well, which is y is equal to 4. So I label the vertical asymptote x is equal to 0. Then I label the horizontal asymptote y is equal to 4. And then these arms, the two arms in the second and the fourth quadrant, you see, in the fourth quadrant, the boundaries does not cross over the boundaries, stays within the line, stays within the boundaries of the asymptote. Same thing here, stays within the boundaries, stays within the boundaries of the asymptote. Are you with me, guys? So that's my second and the fourth quadrant. Jesus indeed is King. He is Lord. He is everything. He is everything. He is actually the joy bringer, the savior of our souls, and he's king. He is king. He never ceases to be king. He's the king of this life. He's the king of this channel. He's the king of just this TikTok page, and those who come to this page, they get life in and through obviously an avenue that I think the Lord is using, which is this platform, just giving people an opportunity to actually have some mathematical knowledge, which can obviously help people see the goodness of God. No one's getting anything undue, if you know what I mean. So hopefully there's clarity there, guys, with that. Any questions, I'm happy to entertain. I get a mark for my horizontal asymptote. Look at it, I've labeled it, y is equal to 4. X-intercept, very nice. My shape of the function, the fact that it is found in the second quadrant and the fourth quadrant. Okay, and obviously, I think just glory, sweet points there. Okay, now who can deprive me of the marks that I need from just sketching so well my exponential and my hyperbola? Okay, and because I understood or understand the parameters a and q, makes life so easy, guys. Makes life so easy because I'm not drawing something that's like I'm going to be shocked about or surprised about. When I understood what a is, I know exactly where I'm expecting to have this function sketched. I know which boundaries it's going to be contained within, and I know what I need to then find my y-intercept, my x-intercept, my asymptotes in place, labeled, and for each arm, at least a point. Okay, you see, there's at least a point for that arm so you can see where it is, and then at least a point for this arm so I can see roughly where it is. And that works nicely. So naturally, when you are given the equation of the function hyperbola, you are given the equation, obviously, you are given the a values there and the q values there. So what you usually do there is you actually check the a value and you check which quadrant according to the a value. Then after you're done with that, you find your horizontal and your vertical asymptote, which can quickly be done because obviously your horizontal asymptote will be given by your q value. Your vertical asymptote will be the y-axis in grade 10. And then after that, you find your x-intercept, which your x-intercept you can find, of course, by letting y be 0. You solve for x. And then after that, you look for another point, whether on the left or on the right, depending on which arm is missing a point. You search for that and you check that out. And you substitute an actual point, any point that you choose, depending on which arm is missing a point. Because, for instance, this arm, from your x-intercept, you're going to get the point for this arm. But this arm may not have a particular point. So what you need to do is you choose a random x value, you substitute it into the function, and you get your corresponding y value. So in this case, remember, they had g of negative 4 is equal to 6, because what they did is they chose a random x value, and then they decided to substitute it into the function so that they could get the output value. Hence, you have g minus 4 is equal to 6, which helps you with the specific point, and then you locate the point, you sketch the function, you are happy. Okay. Any questions? Hopefully there's none. Okay. Yeah. This is functions, guys. This is functions. All right. Yeah. Now I know that just from my understanding, unless people can let me know in the comment section, is our function grade 10 functions only, at least for the algebraic ones. Okay, I know that there's trigonometry functions, but I'm just wanting to check if are we only just for the test that's coming up, are we only just looking at exponential and hyperbola, or we also need to look at your hyperbola function and your straight line, or is it just hyperbola and exponential? And just look at another question that has to do with exclusively, look at this, the graphs of f of x, taken from past papers, guys. These are not just random questions taken from past papers. So the graphs of f of x is equal to minus 4 over x minus 4, and g of x is equal to a times b to the power x minus 2 is drawn below. Okay, it is given that f and g have the same horizontal asymptote. So these functions are drawn in the same system of axes. So let's look at it very quickly. Okay, is my network okay, guys? People in the comment section, quite quiet. Okay, yeah, so we're gonna look at this. Let me know in the comment section if the network is okay, still treating us well. Please, guys, let me know if there are problems that maybe you are experiencing, so that okay, the graph of x is negative 4x minus 4 and g of x is equal to that. It's an exponential function is drawn given that f and g have the same horizontal asymptote. So let's go and check what's the horizontal asymptote that these functions have. So this is f. Look at the f. Look at the shape. The networking. Okay. Yeah. Guys, it's the network that is disappointing me here. The network provider, it is disappointing me. It's not treating me well. The network ain't good. Okay, how's it now? Still not good. Okay, how's the network now? Let me know, guys. Please let me know quickly. The sooner you let me know, the better. The sooner you let me know, the beta. Okay, better now. Okay, neat. All right, I can see the green thing. I just hope it holds up. Okay, the graph of f of x is equal to negative 4 over x minus 4, and g of x is equal to a times b to the power x minus 2 is drawn below. It is given that f and g have the same horizontal asymptote. F and g. So f, look at f. Remember here, let's just look at these guys just to understand. You see, a is native. Remember, we said when a is less than 0, we expect to find the function in the second and the fourth quadrant. Look at it. Look at this. This is the asymptote, the horizontal one. This one is the vertical one, because remember we said the y-axis is always the vertical asymptote. Look at the hyperbola. Second, fourth. You see, a makes sense. We can see practically this is true. When a is less than 0, truly it's found in the second and the fourth quadrant. Then we are told that q is the horizontal asymptote. So that means we know the equation of the horizontal asymptote. Guys, you can see it, because if that is negative 4, we are told here that these two functions are drawn. F and g have the same horizontal asymptote. Now, if they have the same horizontal asymptote, that means that the equation of this dotted nice line here, which is the horizontal asymptote, should be, I'm sure you guys know what the equation is. Then g of x, look at g of x. It's a times b to the power x minus 2. This one. So what are we expecting our a value to be? Q already we will know because it's shared with this. So our q value, I mean guys, if they share the same horizontal asymptote, it means if that is -4, this Q value is also, this is -4 as well. Okay, so we have a lot of things that we can just derive just from looking at the information that is provided in our statement. And if we look at the actual sketch, sense that it makes is amazing. Now, since A and B are there, all right, if we look at the sketch, look at it, it is situated, the exponential function is situated above the asymptote. So what does that mean? Our A value is going to be positive. Our B value, on the other hand, since what? Since the function is a decreasing function, what are we expecting? We're expecting that the B value is going to be between 0 and 1. So already, just from looking, hi guys, okay, let's look at this. What is the domain of F? Let's see if people can help me out. They are asking us for the domain of F. Do we know what domain is? Do we know what domain is? Domain, anyone? What is the meaning of domain? Calvin. This one, look at it. From left to right, what's happening? If you want to know whether a function is increasing or decreasing, you should ask yourself, what's happening from left to right? As you move, what's happening? What's happening here? What's happening with the hyperbola? And here, what's happening? So the hyperbola, A is less than 0, function is, look at it, is it? Hyperbola is increasing. Look at the exponential. What's happening from left to right? From left to right, what's happening to the function? What's happening? You see? Una, you're amazing. Una is saying that the domain is the possible x values for which the graph can exist. Okay. Where do we have the graph? Which x values do we have the graph existing? The possible x values. Yes, Nagobani, you are amazing. Okay, so who is F? F is the hyperbola. So what is the domain of the hyperbola? I feel like I'm alone, like comment section. Anyone want to come up and we can chat about these things? It's actually nice when you hear your human voice that's audible. That's if you are able to actually conversate. You guys can request and we can chat through it. You know, I feel like I'm speaking on my own here, and sometimes hearing your own voice is nice but not nice. Okay, so what would you guys say is the domain of the hyperbola? Yes, you can, Calvin Smile. Come through. Come on down, buddy. Come on down. Or let me request you. Request you before you request me, Calvin Smile. And you can chat, you see. It's better to chat than to smile and to not chat. Alright, so what's the domain, guys? Okay, remember when we look at the domain, we are looking at the function from left to right. So from left to right, for which x values does the function exist? From left to right, we are looking at the hyperbola. Look at the hyperbola. This is what's happening to it. From left to right. So from negative infinity, what happens? Ooh, it seems like it's limited here. Okay, this is where x is equal to 0. It seems like the function does not exist here. Okay, but look. There it is again, from left to right. Okay, goes on forever, infinitely. So there seems to be, the function exists from left to here. But when we get here, what we call the asymptote, it seems like the function does not exist. But then look, it exists again and goes on forever, from left to right. So if we're writing the domain of the function from left to right, what are we going to write down? Okay, so I want you to look at this function. Look at it. This is the function of f. So that means it's existing. The arrow here indicates that it's existing infinitely from left, but then it gets here, and then look, it stops existing. It does not exist at all on this line, this vertical line, where x is 0. But then look, it picks up again, and it exists infinitely, all the way to infinity. So what could you then say is the domain of the hyperbola function f of x? the domain is? Can we write it down? How would we write it? The domain. Okay. So I hope we all understand that we can say x is an element of real numbers. In other words, for x values, the function will exist everywhere, except where x cannot be 0. That's it. X is an element of R. In other words, there it is, the function. Okay, so if you are looking from left to right, the function existing everywhere here, from left to right. But then here on the line, x is equal to 0, the function ceases to exist. It is not possible here. Then you take it all the way after the y-axis, it exists everywhere. Look at it. You see, here it is. It's existing, and it will exist infinitely. Okay, so that's why we can say x is an element of R. X cannot be 0. So are we together, guys? X is an element of R, but x cannot be 0. That is the domain of the function. X is an element of real numbers. In other words, the function exists everywhere for x. The only condition or the place where it does not exist is that x cannot be 0. That is the domain, guys. Simple, straightforward, to the point. Okay, any questions? All right. Okay, if there's no questions, I'll be happy to proceed to the next important, glorious point. Okay, so yeah, that's what we say. X is an element of R. X cannot be 0. X is an element of R. X cannot be 0. Let's look at the second question. Determine the equation of G. Okay, let's go back here. Where's G? There is G. We need to determine what? The equation of G. Where is G? Here is G. Here. Okay, we need to determine the equation of G. Okay. Yes, user, you will lose marks. If you say x is an element of R alone, you will lose a mark, because remember, you need to also indicate that x cannot be 0. You need to indicate that the function does not exist on the vertical asymptote. So that's why you say x is an element of R, to show that the function exists everywhere, with one exception: the function does not exist on the vertical asymptote. Right? So this would be how you would write your domain for your hyperbola function, if the function is a type of function where the function is not restricted. Okay, so in other words, it goes on infinitely in the negative direction, and it also goes on infinitely in the positive direction. So we say x is an element of real numbers. What does this mean? It means for x from left to right, guys, remember the x-axis is from left to right. So that's why I'm saying from left to right, the function exists everywhere except one place where x is equal to 0. So we say x is an element of R to mean that the function exists everywhere for x except where x is 0. So we say x cannot be 0. So if you don't write x cannot be 0, you are going to lose one. You're going to lose a mark, because that's not the domain completely. Domain means possible x value, so you need to write the domain fully. Next question, determine the equation of G. Now, what is G? G is the exponential function. I think already, if you remember, it said that it is given that f and g have the same horizontal asymptote. So already we know what q is for g, because whatever q is for f is what q is for g. So our q value here is -4. That means also we are going to write here -4. So I already have a portion of my function, and I'm going to write it down. G of x is equal to a times b to the power x minus 4. I'm getting close. And guys, look how many marks this is. It's 5 marks. You go determine the equation of G. So I've gotten 1 mark. I have 1 mark already for substituting in the place of Q -4, because of the fact that I was told that f and g have the same horizontal asymptote. So if this Q value is -4, that stands to reason that is also -4. Okay, now we are not done. Let's go to G. G has the point -3 and 12. It also has the point -2, which is for y. So this is 0 and -2. So let's do a few things here. Let's go to our function g of x. Remember, g also means y. Okay, so I'm going to write y is equal to ab to the power x minus 4. Now, this point is -2. It is a point that lies on the function. What is the point? It's 0 and -2. The point is 0 and -2. Remember here, this is the y value, -2. But the corresponding x value at this point is 0. Okay, so we write here, this is the point 0 and -2. So I'm going to say 0 and -2. This is the point that lies on the line. If a point, guys, lies on the particular function, it means that I can substitute when x is what? Here. When x is 0, y is -2. So that means in the place of x, I'm going to put 0 here. In the place of y, I'm going to put -2. So in the place of y, I'm going to put -2. In the place of x, a b to the power 0 minus 4. You see, guys, so what I've just done is I've taken a point, all right, that exists on the function. Since it's a point that lies on the function, what are the coordinates of this point? This is the y value, which is -2, but the x value on the y-axis, guys, is always 0. Everywhere on the y-axis, x is equal to 0. So that's why I know the point is 0 and -2. What is my x value? It is 0. So I substitute in the place of x, 0. What is y? -2. So I substitute in the place of y, -2. Now I'm going to see if I can't solve for one of my values. What's b to the power 0? That's 1. Then I take the -4 over. That's -2 plus 4, which is equal to a times 1, which is a. What's -2 plus 4? That is 2. Therefore, a is equal to 2. Okay, now you go and rewrite the equation. G of x is equal to, in the place of a, I have 2. In the place of b, I don't know what b is yet. So I have a, I'm just short with b. So I go back to my function. Okay, let me just check if people are with me so far. Guys, this here, remember this -4, where did it come from? It comes from this -4 for the hyperbola function, because remember we were told that f and g have the same horizontal asymptote. So if this -4 is for our q value for the hyperbola function, it means the same -4 should actually be here for the exponential function. So that's where this -4 comes from. I need you to understand that first and foremost, the shared horizontal asymptote. After doing that, I check my function. What points does the function have? Now, the reason why I did not go to this one first, but I came here, is because I know that one of my points for this y-axis will be 0. The x value of the y-axis is 0, and the corresponding y value is the -2. So I take the point 0 and -2. How did I know that this is the point 0 and -2? It's because it is my y-intercept. It is situated exactly where the graph cuts the y-axis. So it is my y-intercept. And remember, in my y-intercept, it's where I let what? X be equal to 0, which means this -2 is my corresponding y value. So I take the point, I take the x value, which is 0, I substitute it in the place of x, I put 0 there. I take the y, which is -2, I substitute it in the place of y, there's my -2 there. I hope you are with me, grade 10s. So in the place of y, I have -2 equal to a. Now the a is still there. times the b. The b is raised to the power 0 that I substituted there. Then, but remember, b to the power 0 is 1. The minus 4 follows. Then I solve for who? For a. It is what I can solve for, because it means in this situation where I'm substituting 0 and negative 2, the only thing I can find here is a. Okay? Yeah. And the question that I'm being asked by Unako is, why did you decide to substitute this point exactly? The reason, Unako, why I decided to substitute one of these points and this one specifically to begin with is because had I substituted the other point, the reality is none of my either A or B would have disappeared. The A and the B would have stayed intact. Now, I can't solve an equation that has two variables that are both unknown. Two variables, both unknown. But you see, with 0 and negative 2, if I substitute in the place of x the 0, that means my B is going to disappear and I can solve one of the variables, which is A. And that's the whole point of finding the equation. Finding the equation is about making sure that I can find what Q is, I can find what B is, I can find what A is. And because of the shared horizontal asymptotes between these two functions, I could find easily what Q is by just getting it and substituting it. So I'm safe with Q. The only two things now I need to be safe with is A and B. I need to now find A and B. So 0 and negative 2 is my go-to guy because I can see that this base is raised to x. And remember, if x is 0, that means b to the power 0 is going to allow me to have the variable b disappear so that I can find the other variable, which is a. So that's how I was able to find a, by substituting 0 and negative 2 instead of substituting the other point. The other point would have just delayed me from getting to the answer. So that's why I didn't bother myself, because having A and B still and not being able to solve them is a problem. So 0 and negative 2 helps in that situation. So I hope Unakosoni is working nicely and comfortably in my response. If not, Unakosoni, you can let me know if you don't understand still. Why did say substitute 0 and negative 2? It's because of that very point, that very situation. I wanted to ensure that I'm able to at least get one of these variables sorted out, either A or B. So I substituted then 0 and negative 2. And then you see, b to the power 0 is 1. I have my y value, which is negative 2, substituted. I then solve for a. A times 1 is a. Take the negative 2 over, it becomes positive 4. What's negative 2 plus 4? It's positive 2. That means my a value is what? It's positive 2. So I have a now. Since I have a, I'm going to go and write and fill in. You see? Because remember, this equation is there waiting. I substituted a point, I got a. Now I can take the a that I got and substitute it back. So I now have g of x is equal to 2 times b to the power x minus 4. Now the only thing that is left is for me to solve for b. So I'm going to rewrite y is equal to Unakosoni. I don't know then. If you still don't get it, then I don't know. I really don't know. Okay, maybe you can tell me, what do you get? Because that's important. What do you get? And you see, I've even extended a guest invite so that you can talk to me verbally and you can speak, but I guess maybe you don't have the environment to speak, or maybe people are sleeping, and maybe if you start speaking maths, people are going to be like, who are you speaking to and why? It's so late, right? Yeah. So I don't know how else to explain this to you. It's grade 10 certified person. Right. So once again, just gonna go over it one more time. Remember, firstly, we want to find the equation. The equation is g of x is equal to a times b to the power x minus q. Remember, we found q. How did we find q? It's in the statement. If we didn't read the statement, then we would have had a problem. But because we read the statement, we were able to take care of the problem. Okay, didn't expect that would be the case. Okay, I think I need to change my guest request thingamabobs here because, sorry guys, panel. Okay, you can request again because, okay, I didn't want it that big. When it covers the screen like that, it becomes problematic. Okay, so I was saying here, just once again, it is given that f and g have the same horizontal asymptote. So f is this function, g is this function. If they are saying f and g have the same horizontal asymptote, this says basically that this -4 that you see here, right, is going to be the same value as this q value as well. Because to say you have the same horizontal asymptote for an exponential and a hyperbola function, okay, that speaks to the q value. The q value would have to be the same. So since that is -4, that is also -4. So that's the first starting point. Hence, you see me write g of x, okay, and in the place of q, I no longer just have q, but I have the -4, which is the same -4 for the hyperbola functions q. Okay, that's where we start. Then, secondly, we are told that there are 2 points that lie on the function. The first point is a, which is -3 and 12. 3 and 12 lie on the function. So I could use -3 and 12 to find a or b. But you see, what I'm saying to you guys is that if you substitute -3, which is x, and y, which is 12, the a and b still stay, they don't go anywhere. And I can't even find the values of a and b if both of them are there at the same time. So that basically makes things a bit difficult. So substituting -3 and 12 immediately here is not going to help me with anything. Okay, yeah. Then that's why I resort to going to this point. Now, I need to first discover what are the coordinates of that point. Now, because this is the y-axis, I know on the y-axis, my x value everywhere on this y-axis is going to be 0. So that means if I'm going to ask what is the point here, the point there is 0 for x, and y, which is that -2 value that you see there. If I'm writing coordinates of this point, it's going to be 0 and -2. I then decide not to substitute 3 and 12, -3 and 12, but to substitute 0 and -2. Why? Why do I substitute 0 and -2? Because when I substitute 0 in the place of x, this base with the exponent 0 is going to get me eliminating one of my variables. B is going to disappear, which leaves me with just my a value, which I can then solve and find. And that's what I want. I want to find a, and I want to ultimately find b, so that when I have a and b with q, I can then write down the actual equation of g, which I'm being asked to find. Okay, I repeat. We substitute 0 and -2 as a point. For this function, I already have q. I told you how I found q. I need a and b. But in order to find it, substituting 0 and -2 as the point, this point, okay, because remember, if the point lies on the function, you can actually substitute that point that lies on the function. We don't substitute something that does not lie on the function. So this here, 0 and -2 lie on the function, can be substituted. If they can help me find a and b, please go ahead, let's substitute them. So I substitute 0 and -2. In the place of x, I substitute who? 0. What's b to the power of 0? It's 1. The a is there. The negative 4 is still there. The negative 2, which is my y value, I substituted. There it is. Then I solve for who? Then we solve for a, which is the only remaining variable. Solve for a. So a times 1 is a. Take the negative 4 over, it becomes positive 4. You add the 2, you get 2. So a is equal to 2. And that means I have my a value. Now, I need b. I have a, I need b. How am I going to find b? Well, I'm actually going to find b by substituting at all. Your network is bad. Network is bad. Yeah. Guys, I'm sorry. My network, I don't know what's happening there. It's really doing funny things now. Kevin.
Say.
Yeah, the network, my network, I don't know what's happening. It's almost as if like, I don't know if it senses that there's people coming and people are coming in and it's playing a number. I think the enemy is fighting.
Yeah, I see.
Yeah. So anyways, I don't know at what point. I'm probably guessing because I felt like I was explaining alone, and I think I lost people because the one predominant question people were asking was this one: why is it that what happens here? Why are we substituting 0 and -2? Were you also lost there?
Say.
I'm saying here for this question, finding the equation of the function.
No, say I understand this, but
Oh, you're okay.
yes, I do.
Okay.
You can carry on. Say, you can carry on. Say, I will tell you when I'm not understanding anything.
Oh, okay. All right. Then there's the next question here. It says determine the equation of h if h of x is equal to -gx plus 3. Yeah, well, now this is a slightly different question because they are asking us to determine the equation of a function that we currently don't have at all. So if you look at the question, even from the beginning, the statement, we only know f and we know g, but h, it's not even been mentioned before. But something that we should note in the statement itself is that it says